Okay, hi. Thanks for having me. So let's dive right into it. On this slide, you should hopefully all be able to decently make out the title and read anything. And now if we just change the color scheme a bit, then we get to this here, which, I mean, it's not aesthetically pleasing. I'll give you that, but for most of you in the audience, it should still be readable. But now the point is, if we consider this in colorblind vision, that's what we get. And this is a simulation of the most common type of red-green color blindness. And yeah, this is just a quick example to show you that it's really sometimes difficult for a person with normal color vision to see if some design is colorblind safe or not. So we need some guidelines to follow in order to make sure that our documents are colorblind safe. And yeah, I want to provide some of these guidelines here, but first of all, we have to understand what is color blindness and yeah, how does it work, essentially. So human color vision relies on 3 types of cone cells in our eyes, which means that if a beam of light that is reflected from some object which has a certain color hits our eye, then there are 3 cone cells react in different levels, and the combination of this reaction is then interpreted as color. And yeah, on the right here you can see the typical perception of each of these cone cells. And now when the response in the cones of a particular person is not like you can see in this plot, that's what you call a color vision deficiency. And roughly 5% of people suffer from some sort of color vision deficiency. It's a lot more prevalent in males just because of how the genetics of it works. And for this talk, we will only focus on total color blindness, which means that one of the cone cells, so the short, medium, or long wavelength cone cells, is completely missing, which means that you essentially only have 2 numbers to, or your brain only has 2 numbers to interpret to get to a color instead of 3, which naturally makes it more difficult to distinguish colors. And yeah, just as another example, this is a common test to test for color blindness. On the left, you can see the normal version, where you should be able to read a 74, sorry. And on the right, you can see the version if you are red-green colorblind, where yeah, it's very hard to make out, at least for me, and it's probably even harder with the projector, but you might be able to view a 21. But the point is, this is actually the same image, just the right one is a simulation of color blindness. And yeah, that makes it obvious that we have to choose a suitable color scheme. In this case, of course, it was on purpose not chosen, so it's easily distinguishable. But yeah, if we want everyone to read the 74, we have to use different colors. So yeah, we already saw some groups of colors get basically collapsed into a single color. And there are very typical color combinations in there. So here you can see the red and green, which most of you probably know that is a bad idea to use if you want to make design colorblind safe. But there were also some combinations that I didn't expect. For example, this magenta and blue. Prior to my work on this, I had no idea that that's actually almost impossible to distinguish for red-green blind people. So yeah, we have to pay attention to what color scheme to use in a graphic or in some visual unit. And yeah, for that we first have to understand what are the color schemes that we can actually choose from, because there are a lot of colorblind safe color schemes out there, but not every scheme is suitable for every purpose. And yeah, just here on the right, you can just see 3 different types of color schemes, and I will explain what each of them does. And for that, we just follow 5 fictitious students through a 20-week-long semester. And let's say at the end of each week, they have to take a test, which is graded from 1 being the best possible grade to 6 being the worst grade. and at the end of the semester, their average grade is their final grade that they get for the course. First of all, we might be interested in how the average grade evolves over the course. And yeah, here, first of all, you can see a version of this plot where no color is used whatsoever. And yeah, it's obvious that here it's impossible to extract all the information because the lines cross and we don't know which line then goes where. Now we can add some color to improve this. It's still not colorblind safe in this way, but I will come back to that later. But with these colors, we can at least, it is at least easier to distinguish which line goes where. And now the question is, what colors should we use here? We just have 5 distinct lines that we want to distinguish. So we use a qualitative color scheme, which is used to distinguish between different categories. So the students are not like related in any ways. It wouldn't make sense to put them on a number line basically and then use a continuous range of colors. We just want colors that are easy to distinguish, and you will understand better what I meant by this remark when we go to the next color scheme. Because now we might look at all of the grades of our students, and yeah, the easiest thing to do would just be to put them all in a huge table. And I mean, all the information is there, but it's still very hard to make out some patterns. And in order to make this easier, we then can add some color. And now the color should denote more quantitative information, because now, of course, each of the grades should be a different color, but also 1 and 2 should be roughly similar, and 5 and 6 should be roughly similar. So we put them on we put the colors on a continuous range, and now the important part is in the middle we have a more or less neutral color, because in this grading scheme, a 3 or a 4 is considered pretty neutral grade, and that is reflected by our color scheme. So in the middle we have neutral, and towards both ends we have more extreme grades, like on one side good grades, on the other bad grades. A very similar example is if we now consider our students, well, they might ask questions, as I've been told. We might be interested in how many questions they ask per week, because, I don't know, maybe we want to know if students who ask more questions are better in the end. And yeah, we can, again, just write down all of their numbers in a table. But again, it's hard to distinguish or to make out any patterns. And therefore, we use color again. But this time, like, the question is, what is a neutral amount of questions? It certainly doesn't make sense to just take the average of the number of questions as a neutral amount, because the best possible definition that we could probably come up with is that 0 is just considered neutral because it's the baseline where everyone starts in each week, and then it just gets more extreme from there the more questions they ask. And that's why we use a sequential color scheme, where one end of the range is considered neutral and the other is considered more extreme. Okay, so now we know what these color schemes are, and we know when to use which. We also know that there are like colorblind-safe versions for these color schemes, so we might think, okay, we're good, we just use these colors and that's fine. But the point is there are so many different color vision deficiencies, and it's impossible actually to come up with a color scheme that works well under all of them, because there's even like really strong types of color vision deficiency, like total color, like monochromacy, where you can see a rough simulation of that here on the right, where you can basically only distinguish colors based on their apparent brightness. And now if we look at the plot with the grades from before, it's a lot harder to distinguish the colors because both ends of the range look quite similar. And yeah, because of this, we need additional rules that we have to follow. And there is basically one very, very important rule in colorblind-safe design, which you should always follow. And if you follow that rule, your documents are at least guaranteed to be colorblind-safe. They might not be convenient, but it's a good first step at least. And that is, you should never rely on color only. So any information that you want your reader to pick up, you should make sure that it's not only available in color, but also in some other form. For example, if we go back to our first plot where we looked at the average grade of our students, the only way to distinguish the lines was based on the color. And now if we remove the color information again, we can't distinguish the lines, so we should use something else. In this case, we can just use a pattern. We can dash every second line, and like that it's easy to distinguish the lines. So the main takeaway, if you only take away one piece of information from this talk, it's this one: do not only use color to convey any information, because it just gets lost, and some people will not be able to extract that piece of information from your document. And yeah, the alternatives are usually that you can use some patterns or text to provide the information. And yeah, if you follow this rule, then your documents are guaranteed to be colorblind safe. But as I already said, they might be inconvenient for some readers. And that's why there are a few more rules which you can follow. They are a lot less important than this first rule, but they are still very good practice to follow. And yeah, these are, you should always choose a color scheme and then actually stick to it, because these colorblind safe color schemes that you can come across that are also implemented in my package, for example, they are tuned such that the colors are easily distinguishable. So if you then introduce some color from somewhere else, you have no idea how easy that is to distinguish, which is why you should generally just avoid using colors from different color schemes. In extension, that also means you should not, especially in the qualitative schemes, just mix colors within a scheme, because that also makes the colors less distinguishable. And the same applies for shades of colors, because the brightness is also heavily used in order to make sure that the colors are distinguishable. And yeah, therefore, it's just, you should just pick a scheme and then religiously stick to the colors that are in the scheme and not tinker with them in any way. Then there are two more small rules. Rule number 3 is you should not use color simultaneously for aesthetics and for information. So, for example, in a scientific poster, it's entirely fine if you use color for aesthetic reasons. But if you have some graphic in there, then that just you want to use color in the graphic to convey some information, then you should not use additional color in the same graphic to make it more aesthetically pleasing. Because most of the time you make it harder for people to extract the important information. So it's best not to mix aesthetics and information in your graphics. And this rule might hopefully seem kind of obvious, this last one. You should, if at all possible, try to avoid rainbow color schemes, because there are so many colors in a rainbow color scheme that it's hard even to distinguish for many people with normal color vision. But there are still so many plots out there in scientific papers where you can see these color schemes, so I just wanted to include it still. Okay, so these are some basic guidelines to follow. Now we can come back to LaTeX finally. We can take a look at what colors are available in LaTeX, and of course you can define anything you want basically, but most people will just use the predefined colors because they are the most easy to use. And I will focus here on the 19 built-in named colors that are available in Xcolor or color. And you can see them here on the left. It looks like there are a lot of different options here. And the point is many LaTeX packages just use these colors directly. So for example, in PGF plots, if you create a plot and you don't specify a color yourself, then it just plots the first graph in blue, the second in red, and so on. And yeah, if we now look at the definition of these colors, we already come across the first warning sign. The RGB value for red, for example, is just 100. For green, it's 010. So we can already see these colors are tuned to be easy to define, not to be easy to distinguish. Because if we now, again, turn on our color blindness simulator, these colors get collapsed into basically 3 categories. And we can probably still choose around 6 colors that are okay to distinguish, but there's already black and white in there. So if we remove these, then we basically have 4 colors to choose from. And these are not the most commonly used colors. If we go back here, we can probably pick the leftmost and the rightmost colors, but I've rarely seen pink being used in a LaTeX document. So yeah, this is basically a call to developers. If you develop some package and your package uses color, often it's just an afterthought. You did some cool thing like PGF plots, which is incredibly useful, and then in the end you just are like, okay, people probably want to use color, let's just use some color by default. Please briefly think about what colors to use, because it can make a huge difference for the reader down the line, because most people who use your package will just use the default. And if you spend a bit of thought on this, you can make life easier for a lot of people. Okay, so finally I want to quickly talk about my colorblind package, which is, well, at the moment almost embarrassingly early in the development. So yeah, for the existing tools, there are a lot of online tools out there where you can get some colorblind-safe color schemes, but I didn't find anything directly in LaTeX. So I didn't find any package where you can just easily import the package and then have color definitions available. So my package tries to fill this gap. So far it only provides color definitions of various schemes, like the qualitative, diverging, and sequential schemes that we went through before. And it also provides continuous versions for the schemes that can be interpolated, because the qualitative schemes you should definitely not interpolate, so the continuous version is just not provided. But for the diverging schemes, for example, a continuous version is provided. And lastly, I want to talk about my plans for the colorblind package. So when I started working on this project, my goal was to create a color vision deficiencies simulator in LaTeX, basically. So the idea would be you can write colorblind vision somewhere in your document, and then a certain part of your document gets compiled, and the colors get changed in such a way that it looks to a person with normal vision as it is seen by a colorblind person. So yeah, that's difficult to achieve, and I probably went in over my head there, but here I am. My first idea was to just redefine the color command, which is, yeah, it's a stupid idea, but that's pretty obvious, I think. I mean, it worked well enough to produce all the colorblindness simulations that you saw in this presentation. So it works for some things, but it's very, very finicky, and it's certainly not something that you can ship in a LaTeX document and expect other people to use in a productive way. The right way to go about doing this is probably to introduce a new color model. There is already the color model gray in Xcolor, which just converts all of your colors to grayscale, and I imagine that a similar thing could be done with a color model that's, for example, red-green blindness. But yeah, I don't know that much about how Xcolor works internally, and if someone of you has some idea of where I could read more about that, I would be really happy if you could come and talk to me. And yeah, then the other problem is include graphics is just a whole different story, because you can do certain things with the colors in a graphic that you include, but that is very limited, and I'm not even sure so far if there exists a solution, at least without shell escape. So yeah, if any one of you has any help or like pointers where I can search for something or any feedback in general, that would be greatly appreciated. Thank you.
Okay, thanks a lot for this very interesting talk. I'm sure there are some questions. Yes.
Hi. First, I just realized Barbara asked me yesterday whether we could introduce ourselves at least with the first name when we speak, because it's very difficult to know who is talking on the stream. So I'm Tom, you know me, I hope. But for the YouTube people, hello. I have 3 comments, I hope. One of them is, this is great. It should be, you should get it stable enough so that it's an option for Xcolor. People don't want to load another package. People are lazy. So the less lazy, the more we go towards making it lazy and clever, the better. Just one thing. So you need to talk to the whatever team it is. The other thing is blame David for like not having anything proper in Xcolor already, and that's the best option always. And the last thing I wanted to mention is it is difficult to do, obviously, like, you know, to change anything so that it like looks like it would look to people with any of the deficiencies. But it's the viewers that should be able to do it, of course, right? And Overleaf is to blame. Like, it's very difficult to patch PDF.js, which is the Overleaf's PDF viewer, to just make it like, you know, switch, hey, show me how it looks like to colorblind people. But it's something we should really work towards and try and like maybe push PDF.js, which is, you know, made by Mozilla, to make it an option. You know, like there is ways. So this is something that we should definitely consider. The last thing is, please make a option, change PDF defaults to your package. I'm PGF defaults, sorry, to the package, so that PGF plots uses reasonable color scheme by default if you load the package, because you don't want to patch PGF directly, because then the new versions of the plot someone will mention, and the blue line shows, which is obviously not colorblind friendly anyway, but that's what people do, and then suddenly the blue line will be yellow to everyone, not just the colorblind people, and you are doomed. So we have to be a bit careful. So that's just a couple of comments. Thanks.
Yeah. Thanks for the comments. That's very useful.
Okay. Sorry. So, Boris?
Yeah, sorry for being so active, but I'm relaying questions from YouTube chat. Closing Ingenuity says that for include graphics, you can use decode array, but it's dark magic realm. It's really dark magic because I, for example, don't know anything about it.
Yeah, decode array is what I've been looking into, but you're very limited in what you can actually do with the colors in there. Like you can, for example, remove one of the channels, but that's basically all you can do, and that's not a good, I mean, that's some sort of approximation for colorblindness simulation, but it's a very bad approximation. So yeah, I'm hoping I can find a better way.
Hi, for people in the stream, this is Jeff Kwan. I wanted to ask if you've tried looking at the color contrast ratios between like the colors that your package would use, or if it could tell people like if you could like compute the color contrast ratio.
So I've not done that personally. I've just, because I'm not a graphic designer or anything, I don't know anything on how to choose these colors. So the schemes are not made by me. I've just used existing color schemes online, which are tried and tested. I don't know the contrast ratios, but I could look them up, yeah.
Yeah, if you do like the HTML code, you can just calculate it for you. It's also a legal thing in the United States, which is why I bring that up.
Oh, okay.
So, Nelson?
Yeah, so one comment is that besides the problem of color, it's also the problem of size. And I've encountered this with preparing lecture slides. I see this in student theses a lot, where they use an external program for creating a graphic, And that program assumes that it's going to be displayed in a large sheet of paper. But in reality, in a 2-column journal, it's 4 centimeters by 2 centimeters. And the text becomes far too small to read, and the line thicknesses are often way too thin. And you can see this you can make an experiment with some program where you can easily change the line thickness, display lines of various thicknesses in, say, different colors, like red and black and blue, and then move away from the screen in a classroom. And what you'll discover is thin lines, no matter what their color, look the same. So it's really important to have considerably thicker lines than most graphics packages will produce by default, and to make sure that the colors are distinguishable at various distances, which corresponds to shrinking a graphic for publication. Thanks.
Okay. I think maybe one last short question. Ulrika, just ask him in the coffee break.
Yeah, one comment for your quest to basically simulate color blindness in the PDF file. You can embed ICC color profiles into PDF files, and you can use that to simulate color blindness, but you have to be aware that the reader support for that is rather limited. So I'm not sure which percentage of people would actually be able to see that then.
Okay, yeah, that's also something that I've been looking into, but I haven't been able to find an ICC profile, to be honest, because there are some pages who claim that they have them, but then the downloads are broken or something like that. And I haven't been able to obtain any profiles, so I wasn't able to experiment with that yet.